Hello everybody. So today we're going to be using while loops and nested for loops to apply a mirrored filter from left to right and also a blue line filter to a picture. The blue line filter we're only going to apply to the top half. So I wanted to show you first things first what it will look like when we finish. So you can see when I move side to side, that's that blue stripe filter. And then you can see it mirrors left to right. So, the first thing I'll do is show you the nested loops before I get into the while loops. And so that's where a mirror horizontal comes in. So we're mirroring from left to right, which means we need to first access the width of the picture and then create a vertical reference point halfway through the width of the picture, which we're going to reflect across. So the first thing we do is create int width, int mirror point, and then right pixel left pixel equals null and pixel right pixel equals null. These two are going to come in handy when we are getting and setting color information of the pixels to reflect it for the mirrored image. So you can see that this nested for loop has the y stuff on the outside and the x stuff on the inside. And the reason that we do that is because, and this is where I'll show you a diagram so it maybe makes more sense. Sorry, this is kind of messy. So basically, we are going to loop through all the pixels by going through row by row. Every time we finish going through x values and change information of pixels there, we're not changing the y values. We're not swapping anything in terms of the y values. But once we finish going through all the x values, then, so that's this interior nested loop, then we increment an increase by 1 on the y. And then we just do the same. We do the same thing. We go through a bunch of x values. So this example was gone through on one of the instructor video explanations. And it's basically, to sum it up, you're just going through a lot of x values and then going through one y value and then a bunch more x values. And you do that that's where you can see this orange arrow here. And you do that all the way until you get down to the bottom of the image. So you'll see I wrote some numbers here. What I'm representing with the numbers is the fact that once we loop through the pixels with this nested loop, what we're actually doing with them is we're copying pixel information from pixels on the left side and then sending them to the right side on the correct location so that they are a mirror image of each other. And the way we do this is we have width minus 1 minus x, y. So for example, if we have a pixel at 2, 0, and the width is 10, it's going to get sent to 7, 0. So that's the width minus 10, the width, minus 1 minus x. So that's why 2 plus 7 isn't going to equal 10, but we're always subtracting 1 from that amount because we don't want an out-of-bounds error. And so you can see, like, the distance is going to be greater on the outside when we're having to transfer, like, all the way from the left side to the right side, but once we continue to do this and get into the row deeper and deeper, it's just going to be, like, maybe from 4 to 5, so the distance gets smaller and smaller as we approach that mirror point. And so that is just a representation of the mirroring, and that's the nested for loops. So then, now that we've done that, we're going to go to the while loop. While we were just dealing with pixels in a two-dimensional way for this example with the coordinates, for the while loop, we're just going to be dealing with pixel array, and we're going to be doing it in a one-dimensional. We're going to be representing pixel information in a one-dimensional way. And this is also something that the professor specified in video lectures. So I wanted to include both in this little program. And so yeah, we're not dealing with coordinates anymore. We're just dealing with one long pixel array that is a bunch of stacked rows, but can be represented in just one super long line. And so what we do here is we just load the pixel array. As you can see, we get all our pixels. And then with this filter, as you saw here, we're changing it's like really microscopic here, but we're changing every other pixel to pure blue. And so that is represented in, first of all, the way we index it is going to be, the while loop is going to be indexed by index equals index plus 2. Versus, so that's just how we specify that it's every other pixel. And so it begins, we initialize it, and we're specifying that this filter will run as long as the pixel array, until we get to half of the pixel array length. And then the reason that it is just affecting the top half and not, like, say, maybe like the left half is because of it's because of the fact that we're just stacking rows on top of each other that can be represented in one long line. So we're going from left to right to one row, and then starting over, going left to right again, starting over left to right again. And so that's why at halfway we just stop, because that's half the pixels. So the actual contents of this loop, well, we're going to access, for all the pixels we are dealing with, we're going to access their color information, turn the red and green values to 0 and the blue values to 200. And then we close our brackets. And then this is where I created our picture objects, picture mirror, and then applied mirror horizontal and blue half to the same picture object, and then explored it, just to simplify things. And our result is going to be, I'll just run it so we can all see, even though it's the exact same thing I just showed you, is going to be the picture that has the mirror effect from left to right and the blue stripe effect on top of it. And so here it is. And then I'll zoom out so you can see. Although the lines are so microscopic that it doesn't really show correctly at smaller zoom numbers. But if I did 500, you can probably see the blue stripes more clearly. Yeah. So I hope that was helpful.